5.1b, similar triangles. So we could even talk about this because be more focused, like similar triangles theorems or similar triangle proofs. But what we're going to do is, and you'll see that the definition is pretty much identical to what we had for similar polygons. And here we say triangle ABC is similar to triangle DEF if and only if all corresponding angles are congruent and corresponding sides are proportional. Okay, so again, fits precisely with the similar polygon definition. Okay. Let's see how we can kind of maybe, instead of having all 6 parts, okay, with the angles and the sides, let's see if we can have less information and still determine if they're similar. In this first postulate, we talk about having angle-angle similarity postulate, or we sometimes just write it AA. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. All right? So this is, if you have any 2 triangles, okay, and you can then match up 2 different pairs of angles from those 2 triangles, then you know that they will be congruent. And this makes sense because we know that if these 2 angles are the same as these 2 angles, then the third angle would have to be congruent as well. Okay, because we know triangles add up to 180 degrees. Now, what we need to be careful of is when we are comparing the 2 triangles, we can't just say triangle HJL is congruent to triangle LNM, okay? We can't just say that it's this triangle and this triangle. We'd have to make sure we match up the corresponding parts when we're doing this. So when I write my similarity statement, triangle HJL, I went from double to nothing to single. I got to do the same thing, double to nothing to single, MNL. Now, because we didn't have all the information at the beginning, like we didn't have all 3 angles, and we can't compare the proportionality of the sides because we don't have anything to determine side lengths. Because of that, we have to say why we know they're similar. So we're going to say by angle. Okay, and this is, again, just like we had to do with congruence, with a congruent statement. If we weren't given all the information, we had to say why we knew that they were congruent. All right, same idea here. We know that these are similar because of the angle-angle similarity postulate. Okay. The next one, side, side, side. Now, not to be confused with the side, side, side congruence postulate, okay? Now, you would know that you're differentiating between the two because in our statement, we'd be having a similar, okay? It'd be triangle ABC is similar to another triangle. So when we say side, 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 we'd know that we're talking about a similarity postulate, not a congruence postulate. But let's see how we can determine if we can use the side, side, side similarity postulate. If the lengths of corresponding sides of 2 triangles are proportional, then the triangles are similar. Okay, well, here's what we're going to do. And again, I always like to go small to big, but it doesn't matter. You can go big to small as long as you're consistent. But I'm going to go small triangle, smallest side. That's FD, which is 3. Okay, I'm going to write that down up on the top. Now I'm going to go to my bigger triangle and go to the smallest side, which is 12. Okay, so these smallest sides in both triangles should match up. They should be corresponding. Okay, but let's go to the next one. Let's go to our medium length here, which is 16. And the medium length, the middle length over here is 4. So small to big would be 4 to 16. Now again, if we can use side, 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 all 3 of these that we write down should be equal. We go to the biggest side in our small triangle, 5, and the biggest in our big is 20. So 5, 20. Now, let's reduce all our fractions. 3/12 is 1/4. 4/16 is 1/4. 5/20 is 1/4. They're proportionate because they all equal 1/4. Okay, so we do have 3 pairs of proportionate sides. All right, so that does work. So we can use side, side, side. So let's write down our similarity statement. Triangle ABC is similar to triangle, let's see, ABC. I went biggest length, medium length. Okay, so the biggest length, the middle length. So I got to do the same thing, biggest length, middle length. So FED by, and this one was side, side, side. Okay. All right, we have one more. Side angle side similarity theorem. If an angle of one triangle is congruent to an angle of another triangle, and the lengths of the sides, including the angle, are proportional, then the triangles are similar. Now, we're actually missing the angle here. We're not missing it. It's there because it's a vertical angle pair that we know to be congruent. Now, to figure out, so we know we have the angle part of this side angle side. Okay, with angle right there, it's in the middle. We're good. Now, to determine if the sides are proportional, you've got to be careful here. Just like we did before, I picked the smallest side. I'm going to do the same thing. I'm going to pick the smallest side of the left triangle and the right triangle, 4 and 6. And then I pick the bigger of the two, 6 and 9. Now, these ratios would have to be equal for them to be proportionate. Well, 4/6 is 2/3. 6/9 is also 2/3. So, because they're both 2/3, they are proportionate. And we can use side, angle, side. Right? Now, again, it's not congruent. You don't need these to be congruent. We need them to be proportional to one another. That's why I had to go small to small and then bigger to bigger. So triangle EDC is similar to EDC. So this is where I got to be careful. This is the side I don't know to the smaller of the two. So the side I don't know to the smaller, that'd be 6. So BAC. By side, angle, side. Okay. All right. Those are the different postulates and theorems we're going to be using today. Let's see how we can use them in some examples. All right. Now, if these types of diagrams are confusing to you, and I get it because they're a little bit different. Okay. Let me go ahead and make this red. What we can do is we can focus on specific parts. So what I'm going to do is I'm going to focus on this red triangle right here. All right. And what I'm going to do is I'm going to redraw this big triangle. I'm going to try to. That. It doesn't have to be exact. All right. So I got that triangle. I redrew that. I'm going to go ahead and mark down these different points, the vertices here. So that's A, that's C, and that's B. All right. Now my lengths, that's 2 and that's 4. So this length will be 6, 3 and 6. That length is 9. All right. Now why this is helpful? Because I could combine these and say, all right, well, you know what? This is 6 and this is 9. And again, if you can visualize this, great, and compare the two without having to do all this, that's great. I think this makes it a little clearer for me because I'm focusing on these two red triangles now to see if they're similar. And I do know there is one angle that's congruent between the two. It's because it's shared between both of them. So these angles are congruent. So it looks to me like we're probably trying to set up side angle side. But again, we got to verify that they're proportional to one another. So I go small between these two, between 4 and 6. I pick the smaller. So 4. Between 6 and 9, pick the smaller, 6. And then I see 6, 9. Well, we just did this actually. These are both going to be 2/3. They are proportionate, and there is that angle, so we can use side, angle, side. Okay, now to write down our similarity statement, we'll go small to big. We'll do x, b, z, triangle, x, b, z is similar to triangle. Again, I went smaller to bigger, so CBA by side, angle, side. Okay, there's our similarity statement. And again, it has to include this side, angle, side part if we weren't given all the information at the beginning. Like if we weren't given 3 congruent angle pairs and 3 side lengths that we can then show to be proportional. In this case, all we have are 2 side lengths and 1 angle, but it's enough for side, angle, side. Okay, this example, it looks like a pretty blank slate. Like I don't know anything right off the top. But closer review tells me there are some things we can mark on here. The most obvious one is our vertical angle pair. Okay. We also see these arrows, which means we've got parallel lines. BA and ED are parallel. And what's nice about parallel lines and lines that intersect them both, if I make AE a transversal, I can use that to get a pair of alternate interior angles that are congruent. And I really could stop here, but I can't help myself. I could switch my transversal and do BD and get another pair of alternate interior angles that are congruent. Now, I really didn't need to do all of those. I really only need to do 2 of the 3. And that's because if you remember when we look back, our theorem postulate only required 2 angles in order to say that they're similar. Okay, well, that's all right. We got all 3, but we got enough because we only needed 2. So let's write down our similarity statement. Triangle, let's do ABC, is similar to triangle. I was double, triple, single, EDC. By, here's where you need to be careful. Even though we have all 3, you only need to write 2. Because the postulate's only angle, angle. If I write angle, 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 I'm naming something that is incorrect. Okay, so we want to name it correctly. So we'd want to say angle, angle to represent the angle, angle similarity postulate. All right, last one. Are the triangles similar? If so, why? All right, this is one where we actually have enough information to say these are similar any way we want. Okay, but I'm going to focus just on the sides. Okay, now, while we don't know what these lengths are, we know that these lengths in the small triangle are consistent. They are congruent and they are equal to one another. Same respect, we know that these sides are equal to each other in the big triangle. Okay, all 3 sides are the same length. Not the same as the small, but these are all the same. Okay, that fact tells me that if I were to match these up in any way from small to big, the small side to the big side will be proportionate because it's the same lengths. Okay, and because I have 3 pairs of proportionate sides, I can use the side-side congruence theorem. Okay, so I can write down triangle ABD is similar to triangle. It does not matter how I write this because they're all equal. All right, so I'm going to do alphabetical. We'll do EFG by side, side, side. Now, it's not always going to be like this. You might be given numbers, and the triangles won't look equilateral. But again, the key I just said there is these are equilateral triangles because they're congruent sides. Well, we know in all equilateral triangles that they're also equiangular triangles. So these angles are all equal. Well, guess what? If they're all equal, they're all going to be 60. And all these are going to be 60. So we actually have enough to say we could prove that they're similar just by showing the 3 different angle pairs and the 3 pairs of proportional sides. We also could use angle-angle. All right, we could use side-angle-side. We could use side-side-side. It works for all of them in this case because it's an equilateral triangle. And we know some facts about equilateral triangles.